Now, this has to be the cheesiest of the cheesiest animations I've ever made, but I wanted to do something to help you visualize affinity chromatography. And if you assume that the picture that I've drawn here is a beaker, and in this beaker we have a few things. The kind of turquoise looking beads are what we would consider the sort of stationary phase. They're going to be the eventual stationary phase in our column. They're the beads that have on them the inhibitor that might bind to an enzyme. So when we look at the three enzymes that I've drawn in here, one of them kind of in a brownish tan color, one of them in a blue, and one of them in the red, clearly it's the red enzyme that we're interested in. That's our target enzyme to purify. We can see that because the inhibitor on the beads is going to specifically bind to the active site of this particular enzyme. So we would begin our experiment by putting all of the cell prep that we had taken from maybe some organism, whether we're taking it from blood or somewhere that we want to purify an enzyme from, and then we're going to put it into solution with the beads that will eventually be used in the chromatography. But we know that in that solution there are many enzymes. I've just shown a couple of impurities, but there could be many other enzymes that are not the enzyme of interest. So what we'll see then is once we put the enzyme of interest in with the chromatography beads that have the inhibitor on them, we'll mix it around. And what we're hoping is that in this mixing, we'll get the specific binding of the enzyme to the inhibitor on the beads. And of course, the other enzymes that don't bind specifically to that inhibitor will not bind to the beads. So this whole first goal is just a mixing, which I know, cheesy mixing a cartoon that I have here, where you see it mixing around, and eventually at the end of this mixing, we hope that in fact the enzyme of interest to us has firmly bound to the inhibitor on the what will become the resin beads. So now you can take what we call it a slurry at this point, where there's a slurry of the mixture of the bound enzyme and the eventual stationary phase beads. We take the whole thing and pour it into a column now, and that the beads pack the column. But of course, still in that solution is the firmly bound enzyme that we know we want to purify, but there's also the other two enzymes that we're not interested in having in our purification. So now drip mobile phase across this column, and the mobile phase will cause the non-specifically bound proteins to elute. So those will get set free coming out of the end of the column. Now at this point we can add a competitive inhibitor, a free inhibitor that will bind to the enzyme and take the place of the inhibitor on the beads within the stationary phase, and that will allow the enzyme of interest to elute. So depending upon what you're working with, you might use different things to elute this enzyme, but a free inhibitor might work really well. So let's watch as a free inhibitor comes in, binds to the enzyme, frees it, and lets it elute. So then you would be able to look for your A280 readings and find the enzyme that you want to purify.